Hello and welcome to this video on ratios. In the first part of the lesson, I'm going to introduce ratios and talk about how to simplify them. I'm then going to go on and give you 3 examples of typical exam questions that you will face. If you want to navigate around the video, as always, the links are in the video description. Okay, so what are ratios? Ratios are a tool that allow us to compare the amount of one thing compared to another. Let's think of an example. So if we were to go on a hiking trip, we would need to prepare our equipment for the hiking trip. And we might have 1 tent per 2 people. This would therefore be a ratio of 2 to 1 of people to tents. But we might also be bringing cooking equipment, like a cooking stove, where we might share 1 cooking stove between 4 people. In this case, the ratio of people to cooking stoves would be 4 to 1. Some scientists suggest that ratios are a much more intuitive way for humans to compare the numbers between groups of items than actually comparing the total numbers of items in each group. Pierre Pica is a scientist who studies indigenous tribes in the Brazilian Amazon. He especially looks at how their number systems work. And he believes that the reason that ratios are a much more intuitive way of comparing values for humans is that when we were living on the savannah, it was much more important for us to be able to quickly ascertain whether or not there were too many lions in a pride for our tribe to be able to defend ourselves, rather than comparing the exact numbers of lions in the pride and comparing that to the exact numbers of humans in our tribe. You need to be able to simplify ratios. Let's use an example of girls and boys in a rowing club. Let's say there are 15 girls for every 9 boys in a rowing club. This would give us the ratio of 15 to 9. We can simplify this ratio by dividing both sides by 3, because 3 is a common factor. This then gives us the ratio of 5 to 3 girls to boys in the rowing club. This also works when we have ratios with 3 numbers in them. If we had a ratio of 20 to 16 to 10, all of these numbers divide by 2. So we could divide all 3 numbers by 2, and this would give us the ratio of 10 to 8 to 5. There are 3 typical types of question that you will face on ratios in your GCSE exam. The first type of question is what I like to call the find one part question. In this question, you are told a ratio and you're told one other piece of information. This piece of information might be the exact numbers in one of the groups or the exact number in both groups combined. You might then be asked to find the value in the other group or find the total depending on what piece of information you've been given. Let's look at an example. Let's say in a zoo there were 7 penguins for every 2 lions. If there was a total of 90 penguins and lions, you might be asked how many penguins are there in the zoo. We do this by finding one part. What we mean by that is when we have the ratio of 7 to 2, each one of those 7 and each one of those 2, how many penguins or lions does that one part represent? We find this out by adding together the 7 and the 2 to get 9 parts. And we then divide the overall number of animals by this number of parts to find out how many animals are in one part. 7 plus 2 is 9, and 90 divided by 9 is 10. So we have 10 animals per part. We can then quickly ascertain that there are 70 penguins in this zoo and there are just 20 lions. The second type of question that you're going to face is what I call the ratio fraction question. This is where you're told the ratio between 2 different amounts, and you're asked what one amount is as a fraction of the total. Let's use the example of a cup of tea. Let's say we have a cup of tea that has water to milk in the ratio of 4 to 1. You might be asked then, what fraction of a cup of tea does the milk take up? We can think of this by thinking about how many milliliters of milk there are for every milliliter of water. Because we have the ratio of 4 to 1, that means for every 4 milliliters of water, there is 1 milliliter of milk. Therefore, within every 5 milliliters of liquid, 1 of those milliliters is milk. And we can clearly see that 1/5 of the overall cup of tea is milk. The final type of question is what I call the changing ratios question. This is where you're told the ratio between 2 different amounts, and you're told the absolute value, the exact value of one of those amounts. You're then told that some change happens in the absolute values, and you're told to calculate the new ratio between the amounts. It might work something like this. If 12 eggs were hidden for an Easter egg hunt, in the ratio of 3:1 of eggs to children on the hunt, you might then be asked, what would happen if 2 more children arrived for the Easter egg hunt? In order to complete this question, you want to work out the exact values of, in this case, children and eggs in this scenario. We can manipulate the ratio of 3:1 by multiplying both sides by the same number. This is the opposite of simplifying it, and we multiply both sides by 4, giving us the ratio of 12:4. This clearly tells us that if there were 12 eggs, which there are, there would be 4 children in this Easter egg hunt. We now have the exact values for both of the amounts, and we can then add on our 2 children to the 4 children to see that there are now 6 children, but there still are 12 eggs. We create this new ratio of 12:6, and we simplify it down by dividing both sides by 6, giving us the ratio of 2:1 for eggs to children in our new Easter egg hunt.